So, remember I said, just like slope with y equals mx plus b gives you that pattern so you don't have to do an xy table every single time, right? These things have patterns too, and that's what we're going to talk about. We're going to talk about those patterns to help us graph them a lot easier than xy tables and all the calculations that come with that, okay? This is fine, it works, but it takes a long time, right? Especially when these things get crazy. Like, what if you had y equals x minus 3 squared plus 10? Well, now this is going to get real hard, right? So you don't need to do these calculations if you know the pattern and you know what this -3 and this 10 do, okay? So that's what we're going to talk about. So let's talk about the pattern, okay? In the parent function for a quadratic function, there are key points. And these key points are the key to the pattern, okay? Here, 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 right? 7 of them, right? Most of the time we can find at least 5 of these, okay? So let's talk about the pattern that exists here. The key points pattern. Okay, so remember with y equals mx plus b, we always needed a starting point. We needed our b, right? So we need a starting point here as well. And our starting point is going to be our vertex. Anybody remember what a vertex is for a parabola? The bottom part, right? This right here is our vertex. Because that is our turning point. Right? Wherever the function turns in a parabola, or in an absolute value for that matter, is our vertex. It goes down, 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 and then it turns and it goes up, up, up. That's our vertex, and that's our starting point for these, okay? So first thing is we start at the vertex. Okay, and we continue to start at the vertex every single time with our pattern, okay? And then we go, zoom in a little here. We start at the vertex, we go over 1, up 1 to get our first point, right? So over 1, up 1. Then we go back to the vertex, and we go over 2, up 4, right? Over 2, up 4. And then if we can't always, but if we can, we go, another color here. Let's see, we'll go with blue, over 3, up 9, okay? Okay, so that gives us 1, 2, 3, 4 points, right? Yeah. Okay. Now, how do we get more? What do we think? We don't need to calculate anything. I got 1, 2, 3, 4 points so far, and I want, let's say 3 more. Yeah, you have 2 options. You can go back 1, up 1, back 2, up 4, back 3, up 9, or you can flip them all over the axis, right? So we can then flip points over the axis, okay? Because, and to flip, think about it, this is 1 away, this is 1 away from the axis. This is the axis, right here. This one is 2 away, this one is 2 away. This one is 3 away, this one is 3 away, right? So it gives you 3 more points, and that gives you 7 points. And notice I have not done any XY table work. I knew that it started at 0, 0, and then I just knew the pattern, right? And that gave me every one of these points. Here, 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 here. And that gives me my shape. That gives me my parent function, right? And I haven't had to make an XY table, right?
Wait, how do you flip it?
So remember that this thing down the middle cuts it in half, right? So if I know that point, and that point, and that point, I can flip each one of them over and get more points. And how do you flip? Well, you just go 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 1. They're equidistant from that spot, okay? All right, so that's the pattern for that one, right? And if we know that pattern, it's gonna help us when things start to move around and get more complicated, okay? Now let's talk about the pattern for this one.
Mr. Sean,
Yeah, what's up?
is that the over 1, up 1, is that gonna be the same for all of them?
For all parabolas, for all quadratics, unless they're stretched, but that's a lesson far in the
So
future.
for the second one, are we gonna do the same thing?
We're gonna find the pattern for the absolute value function,
Oh,
and that'll be a different pattern, okay? So you wanna know the patterns for each one. All right, so same thing, the pattern. Is you start at the vertex, and this one's actually a lot simpler. You go over 1, up 1, right? Over 2, up 2, over 3, up 3, and then flip all those, and then you have that one, right? Okay, and then you can keep going. You can add more points, over 4, up 4, right? So that gives us this pattern. And knowing these key points and this pattern will help us when things start to get more complicated, right? When things start to change, okay? So that's what we're gonna start to do now, okay? So, any questions, any other questions here before we move forward on these patterns? Okay, so here, we have this function, right? X squared minus 4. Things have changed a little bit. We see our parent function here, and then somebody added a minus 4 at the end, okay? So what we do is we don't say, okay, I guess I'm gonna make an XY table and plug in a bunch of X's and figure out what they are. We just graph the parent function and then move it, okay? So this is the parent function, right? So if I gave you this problem, I might give you a blank graph and you have to add this parent function. So you know you got 0, 0, over 1, up 1, over 2, up 4, right? This one doesn't go to 9, so we're not gonna get there. Back 1, up 1, back 2, up 4, right? So that gives you your key points of your parent function. And then I'm gonna show you what happens when you graph this function. And then you're gonna answer these questions on your own, and then we'll talk about it, okay? This function, x squared minus 4, looks like this. Looks like that. So add this, add both the key points and these red dots and this red function to your graph, and then answer the questions about what you think happened, okay? And then we'll talk about what we've learned and what we can take away from this, okay? So you're answering those questions, right? The last one, don't worry about. That was when I was gonna have you use Desmos, but I'm just gonna demonstrate it for you instead, okay? Now remember, this blue function right here, that's our parent function. That's y equals x squared, right? And we're using it to help us graph this function, this red function, okay? Now, look at the blue function and then pretend somebody moved it and made the red function. How did they move it?
How did you get the red buttons, like the red dots?
That's what we're about to figure out. That's what I want you to think about.
But like we drew them, how do we know?
That's what the first question's asking. What do you think? How do you know? Does anybody think they know? How did we get these red dots?
We did x squared minus 4, like we're doing 9, we're doing minus 4, and the point that was at 9, we're put at 5.
Okay, so it sounds like you did some calculations there. Anybody do without calculating? Yeah.
You just use the pattern from the first function.
Yeah. Want to add to that?
You switch the y-intercept from 0 to -4.
Okay. Yep. Anybody want to add? Those were good, right? So what happened was every one of these key points, right, moved down 4. Every point moved down 4, right? This is called a transformation. It's when a function shifts, right? Or does other things. So we're just talking about shifts today. Yeah?
But the like 2 up buttons, like the red ones, how
Mhm.
do we get them? Like not the one that.
Oh, I knew they were there because I knew there was points up there. I guess I shouldn't have added those because that was just me remember. Because of the pattern, over 3 up 9. That's how I knew. Remember the pattern from up above. Remember, over 3 up 9, right? Over 3 up 9. That's how I knew, okay? All right, so what happened here? All the key points shifted down 4, okay? All the key points shifted down 4. That's all that changed, right? So what do you think would happen if we did x squared plus 5?
Let's go 5 up.
Yeah, it would just go 5 up. Oops. I don't love these. Just gonna draw these a little clearer. Yeah, so this would shift the function up 5, right? And do you have to calculate every one of those points using an XY table? No. If you know where the parent function is, and you know each of the key points, you just move each of the points up 5. Okay? All right, so with that knowledge, knowing that this happens, we're going to try some. But first, let's define what exactly what we learned here, okay? So we'll write this over on the side here. So what happened here? Well, we learned that if you add or subtract, and I'm going to use a word here that will make more sense when we get to the back, outside a function, shift up or down, okay? And if it's positive, you go up. If it's negative, you go down. And you do it one key point at a time. So it's all the key points. Okay? Now when I say outside, that's going to make more sense when you see inside, okay? Outside just means it's like at the end, after the function, okay? All right, so now I want you to try these three with that knowledge, okay? So try these three. So know your key points, and then shift each one based on what you think this is telling you to do, okay? And remember, this is your rule right here, okay?
But why did you put y equal x squared and then you do that?
Because the blue one is our parent function, that's x squared, and then this one was x squared minus 4. So we use the first function to help us find the second one, okay? Good question. So again, we're trying these three, right? And I would not recommend trying to get ahead and do these. This behaves a little differently down here. So just try these three, and then we'll go over them, okay? These are gonna get a little crazier than just x squared plus 2. So there's a process that I recommend that I'm gonna start now. And you're gonna be like, well, it's kind of obvious, so why do I need to write that out? Because you're gonna eventually get a function that's like y equals negative 2x plus 2 squared minus 4. And there's a lot going on. So you're gonna wanna pick apart all the little pieces in there. So let's start picking apart pieces now. Now this only has one thing going on. It's got our x squared, and then what was added? Plus 2. So I circle, highlight, color it, and then I write down what that tells me to do. Plus 2 tells me to go up 2. So I say, okay, up 2, right? And then I take each key point and I do them one at a time. And I say, okay, up 2, up 2, up 2, up 2, up 2. And it reveals my shape to me, right? Now I see, oh, this is the parabola, right? This one, minus 3. So it's my absolute value function, and it's going down 3. So again, I find key points, and I move them all down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And it reveals my shape to me. Okay? And this one, of course, would be up 4. So I find my key points and I move them all up 4. Okay? These are what's called transformations. Oh, I didn't move them up 4. Move them up 1. And it gives us a shortcut. And now I have the graph for absolute value x plus 4, but I didn't have to do an xy table. That's the whole idea, right? All right, so that is vertical, meaning up and down, vertical translations. But that's not the only way we can move, right? We could also move left and right, okay? So we're gonna talk about that now. So again, I have a function. I have this parent function, y equals the absolute value of x, and it's got its key points, right? And then this thing happened. Now, what's the difference between this one and this one? It's inside the absolute value. And that's the key difference. You gotta notice, are things happening inside or outside? Inside the absolute value, inside the parabola, or outside the parabola, right? Inside the square or not, okay? So this is inside, right? And watch what happens. It might not be what you think would happen. So now answer the questions. So add this graph, right? And then answer the questions on what you think is happening. And like I said, it might not be what you thought was going to happen, but this is what happens. So again, when you're answering this, you want to be saying, like, what happened to the key points? How did they move? Okay? And each of my key points, in this case, what happened? Where did they go? They went to the left.
Right.
They went to the right, right? So all my key points shifted right 3, okay? So I had x minus 3 on the inside, and then I went right 3. So what do you think would happen if I had x plus 5 on the inside?
They move 5. How?
Hmm?
They would move 5.
Which way?
Right.
Left. Left. You would shift left 5. Yeah.
Wouldn't it be the opposite? Because negative.
That's the hardest part for students to get a grasp on, okay? With the y values moving up and down, like when we had like y equals x squared plus 3, right? It moved up 3 because you plug in and then you add 3. So that just moves everything up 3.
Oh.
But this changes your input. It changes what goes into the function. It changes your x. So think about it. This is 3, right? If you plug that in, 3 minus 3 is what? 0. So the output becomes the absolute value of 0. So the output is what would have happened here normally, right? Here I have 4. 4 minus 3 is 1. So the output ends up being what would have happened at 1, right? It changes your input, not your output. So it shifts it opposite the way you think it would. Yeah?
So if it's within the brackets, it changes the input. If it's out of the brackets, it changes the output.
Exactly. Yeah? Go ahead.
And when it's when the inputs change when it's in the brackets, and it's a positive, it moves to the left, and when it's a negative, it moves to the right.
Exactly, and that's the key takeaway. So there's, anytime in this class, we're gonna talk about procedure, steps, tricks to remember things, and we're gonna talk about the why. So you wanna know both, but at the very least, you do wanna remember the steps. So definitely, I'm gonna give you this, the trick, the thing to look for. But if you wanna know why, we're changing the input. So instead of 3, I have an input of 0, so I get the output that normally would have went with 0. Instead of 4, I have an input of 1, so I get the output that normally would have went with 1. Okay? It's a little hard to grasp, and sometimes it clicks after you've done a lot of these, so don't worry if you're like, oh, what's going on? Question?
But every time we have like these things,
Mm-hmm.
with right and left,
Mm-hmm. Yep. Yep. And the same goes for if you have like y equals x minus 2 squared, right? It's inside the parabola.
everything inside something, we go left and right.
Yep. Exactly. Right? So let's write down a rule here, okay? So here's our rule. So if you add or subtract, and this is why I said outside before, because now we're inside the function and something different happens, right? Now you shift inside a function, you shift left or right, and the key thing to remember is it's kind of the opposite of what you think might happen. If you're negative, you should go right. If you're positive, you go left. Okay? There's 2 ways. You can remember that, hey, I'm changing the input, or you just memorize that. On the outside, you move up and down with the sign. On the inside, you move left and right, the opposite of the sign. Okay? So, with that in mind, with those tricks in mind, try the bottom. Now, remember, get your key points first and just move every key point one at a time. Okay? So try those bottom 3, and then notice in this last one, like in this first one, you got a +2 in there, right? In the second one, you got a -4 in here. But in the last one, I got a +4, and then I have a -2 on the outside. So possibly more than one thing's gonna happen, okay? So try those. And here's the deal. If you, because this has been asked a few times, right? And then I'm gonna come around and help people individually. All right, we did an example with absolute value, so it was like, well, what about when it's a parabola? Now do I have to worry about this exponent? So here's the deal. I'm gonna eventually ask you to graph this, and I'm not giving you anything. I'm just gonna give you a blank graph, right? And this matters because it tells you the parent function. It tells you, oh, I'm dealing with x squared, right? So it doesn't not matter. You need to be able to see, oh, it's quadratic, so that's the parent function. So I got this thing I gotta add. And then that's all you need to worry about it for, because then the -4 tells you take your parent function and move it to the right 4. Okay? So it matters, but not in terms of we're not calculating points. We're not doing an XY table right now. We're just shifting based on transformations. Okay?
And the -2 at the end, does that also matter like now?
So that, remember from the front side of the paper? That tells us to go where?
So we first have to go left or right, then we go up or down.
Yep.
So both.
1 point at a time. So you would say, okay, here's a point. I know it has to move left and it has to move down. And then I make a new point. Okay? These last few examples, so make sure they're fully explained with any questions that we had. And then I'm gonna get you started on your homework, and then then you can work the rest of the theory. All right, so again, this is telling me, hey, go left 2. So all my key points, one at a time, I'm gonna move them left 2. 1, 2, 1, 2, 1, 2, 1, 2, right? 1, 2, 1, 2, 1, 2. And that gives me this. This one is telling me, hey, go right 4, right? So I go 1, 2, 3, 4. Now, at this point, you have 2 options. You can take every point and move it left, right 4, or you can remember the shape of a parabola. Over 1 up 1, over 2 up 4, back 1 up 1, back 2 up 4. And you gotta be careful with that, because I saw some people going up 5 or whatever. You always go back to the vertex and then go 2, 4, okay? This one, we have these points, our key points. And I'm gonna move my parabola left 4 and then also down 2. So I go 1, 2, 3, 4, 1, 2. And again, you can move every point one at a time like that. Or if you remember the pattern, you know your vertex, over 1 up 1, over 2 up 4. All right, now on your homework, it's asking you to write an equation for each one of these graphs, right? So you gotta think to yourself, okay, I know this is 0, 0, and my parent function would be here. So where did this move? So for example, this one went up 2. This one went right 4. This one went down 6. This one went left 7, right? So let's take D for example. It went left 7. So when we're moving right and left, are we inside or outside? Inside. So I open up some parentheses and I say x and I put a squared on it. And if it's going to the left, then it's going to be plus or minus? Plus, because it's inside. And how much did it move? 7. So that's how you would write it. Okay? And if it was moving up or down, I put it on the outside, which means I just have x squared. Okay? All right. Yeah.
Say that again.
So for instance, if look at A, it moved up 2, so there's nothing changing on the inside, so it just stays x squared, right? And then it goes up 2, so I would go plus 2, because it's going up 2, okay? All right, good luck.